Good morning to the session chair and all participants of Flight Software Workshop 2016, the third day. Our talk is on architectures for delay, disruption tolerant network implementation for space. I am the speaker, Unnikrishnan, and Mr. Sudhagar S. is also available here. Other co-authors are Ravichandran and Subramanya Udupa. Next slide.
Yeah. Okay.
The overview of the presentation is, we'll introduce what is DTN, and the DTN architecture will be explained. Then underlying protocols of DTN will be explained. Then study on the DTN2 reference implementation. Then the architectural components, design models for flight implementation, and we have different implementations: hardware implementation on VHDL, embedded processor-based implementation, software implementation on a single board computer, and all this will be compared and it will be concluded. Next slide, please.
Yeah.
The DTN objective of the DTN protocol is to integrate the networks of different communication characteristics. It's called regional networks for its seamless operation. The examples of regional networks are mobile network, sensor network, space network, terrestrial network, like internet, etc. The communication characteristic of a network means the connectivity of the nodes in the network, that is, whether they are always connected or is it intermittently connected. The other parameter could be the path delay, whether it is a long path delay between nodes or a short delay between nodes. Then bit error rate or packet loss, is it high like a wireless network or is it low like a wired network? Then data rate, it's whether it's asymmetric or symmetric. Then usually the underlying protocols are optimized for the characteristic of this network characteristic for maximum performance. DTN, the idea is to make the application transparent to the above communication characteristic in an inter-regional operation. Next slide, please.
Okay.
It's a typical DTN scenario where we have three regional networks of, one is a sensor network named network A, other is a satellite network named B, and other is a network C, could be internet. Now the protocol within the region is optimized and they are interconnected using DTN gateway, where we can see two gateways are connecting satellite network to other networks. In this example, say node A1 in the network A wants to communicate to node C2 in network C, and currently there is no connectivity for the network C with the other networks. So in this scenario, the application at the node A1 will be transparent to this, and the messages will be delivered to node C2 in the network C when it joins the network within the lifetime of a message. The operation as a parallel with the email operation. Next slide.
Okay.
The DTN, how DTN works. The transport layer is terminated when there is a network partition, which means there is a disruption in the network or there is a long delay. A store and forward message switching mechanism is embedded in the network architecture. Messages are stored in a persistent storage in this architecture when the networks are partitioned. A new overlay protocol called bundle layer is introduced above transport layer. If these bundles are moved towards the destination hop by hop at every opportunity for the delivery of messages. Next slide, please.
Okay.
A new overlay protocol called bundle layer is introduced above transport layer, and also DTN protocol stack is compared with the internet stack, where here we can see above transport layer there is a bundle layer and an associated persistent storage in bundle layer. The lower layers will be always network specific. Next slide.
Okay.
The protocol features are, as we have seen, it is a store and forward message switching. The bundles are the reliability and a custody transfer is a protocol feature. The bundles are reliably delivered to the destination by a mechanism called custody transfer. That means a designated intermediate nodes take the custody of the bundles and release the resources at the source. The bundle delivery is acknowledged asynchronously to the source. Then there is time stamping and time synchronization. When a bundle is created, a timestamp is generated along with a bundle lifetime for the bundle delivery before the expiry of the bundle lifetime. A course level time synchronization is required for the correct operation of the protocol for its routing and forwarding. And fragmentation and reassembly. The bundle fragmentation at the source is done by dividing the application data unit into smaller blocks and reassembling at the destination. If required, this is done for effectively utilizing the contact period of the connectivity. Otherwise, a partially forwarded bundles are to be retransmitted by consuming the network resources. The contact volume can be predicted, or if it is known in advance, a proactive fragmentation is done. Otherwise, it will be a reactive fragmentation. And also there is a congestion control mechanism. The traffic into the network has to match with the traffic going out of the network for controlling the congestion. In DTN scenario, nodes will retain the bundles due to disruption for long time, which will ease the congestion. So congestion actually occurs in DTN when storage becomes scarce or limited due to the presence of too many messages or the too many bundles. For this, the different strategies are worked out in the protocol. One is to expire the bundles which are accepted by the node, or discard the bundles which are already expired, or stop accepting further custody. These are the different strategies to control the congestion in the network. As a last effort, the messages are deleted for which already control is taken by a node. And then the security, when bundle security protocol addresses this by introducing different security mechanism called bundle authentication block that ensures bundle authenticity and integrity from hop by hop mechanism. And also payload security block also introduced for the authenticity of the payload. A confidentiality block is introduced for the confidentiality by some encryption scheme. The key management of the system is also defined in the security part of the bundle protocol. Next slide.
Okay.
This is the bundle format where there is a version number. 06 is the version number defined by the standard. Then bundle processing control flags is explained in the subsequent slide. And we have a block length, then destination scheme offset, destination scheme specific part offset. Actually, this is called the endpoint identification. It has two parts. One is the scheme part and the scheme specific part. So we in the protocol framework we have a destination endpoint identification, source endpoint identification, report to endpoint identification, then custodian endpoint identification. The creation of time is also put in the bundle. So this is the time at which the bundle is created in the network. And at the same time, more than one bundles are created. There is a sequence number in the bundle. It will increment at the creation of every new bundle. And also there is a lifetime for each bundle, which will define the valid period of the life of the bundle. We have a dictionary part in the protocol. It's an array of bytes formed by concatenating the null terminated scheme names and the scheme specific part. And this offset is referenced. This will reduce the header size. Next slide, please.
Okay.
So this is further the different control flags, which will tell whether bundle is a fragment or whether it is an administrative control or bundle not to be fragmented, custody transfer is required, or whether destination endpoint is a singleton, acknowledgement by application is requested, and other fields are for the class of service. It will give different priority for a bulk, normal, expedited. These are the different priority level defined, and also the acknowledgement mechanism are controlled by making use of a few bits here, whether after bundle reception, acknowledgement will be sent. After taking a custody acceptance, acknowledgement will be sent. Bundle forwarding, bundle delivery, bundle deletion. For all this, whether an acknowledgement is required or not, these bits will be defined. Next slide, please.
Okay.
This is the administrative record, which will say the bundle status report and custody signal. This also, if it is a custody signal, if it is a redundant reception or storage is depleted, destination endpoint ID not available, these are the signals will be sent to the source ID, source EID. Next slide, please.
Okay.
To begin with our DTN development, DTN2 reference implementation, we have configured and evaluated on a 3-node Linux network and simulated the DTN operation for a typical configuration of a ground node, orbiter and rover on this test bed. And also we have simulated a command file delivery to rover and telemetry reception at ground for intermittently connected links. The links we have simulated on LAN. This proved the concept of DTN operation over a disrupted link where other protocols fail to operate. We have seen that we have tried with the TCP in a scenario where it failed. The contact graph based routing was configured for this simulation. Next slide.
Okay.
Next slide. DTN simulation test bed. We can say each PCs are configured using Linux operating system and reference implementations are configured. Node 1, 2 and 3 are configured with DTN2 reference implementation and simulated as a ground node, orbiter and rover. Links are simulated on LAN and links were disrupted with the help of a test script such that no time the ground node will have a direct connectivity with a rover. In this scenario, we have sent a command file from the ground node and delivered the command file to the rover, and in a similar way at the ground we have received the telemetry file through this disrupted links. The contact graph was maintained at each nodes for routing or rather forwarding the bundles. Next slide.
Okay.
This is our DTN prototyping on a FPGA. This is a hardware implementation. We have scaled down the implementation the specification, and in this configuration, the endpoint identification is a singleton, so only a unicast is supported. Otherwise, the protocol supports a node as an EAD. A group of EAD can receive the bundles, and this is a storage. 4 memory blocks are used as a storage. That means at the most 4 bundles will get stored in the network nodes. DTN timer resolution is 1 millisecond. 3 level of priority we have defined for normal, bulk, and expedited. Lifetime of the bundle we have defined as 10 minutes. Bundle size is 10 bytes, and the payload size is 956 bytes of payload application data unit. And also we have implemented SDNV, encoding and decoding. SDNV is self-delimiting numerical value, so that the protocol headers size can vary. But since it is a hardware implementation, we have restricted this encoding decoding of SDNV, and a contact graph based routing is used for forwarding the bundles. In this implementation, security is not addressed. This is a test setup for the prototype validation. The implementation was Next slide, please.
Okay.
This is a test setup for prototype validation. The bundle layer is implemented on a Xilinx FPGA, and from a PC application data unit or bundles are sent through RS-232 port. The persistent storage is built on RAM blocks in the FPGA, and the simulation level testing is done, and coding VHDL is used for coding. System frequency is 4 MHz. Xilinx Vertex 4 is used in the configuration. Next slide, please.
Okay.
These are the major VHDL modules. We have UART receive module in the receiver DTN node, and we have SDNV encode and bundle formation module and persistent storage module. Then at the receiver side, we have SDNV decoding module and a block decoding, then extract application data unit, then UART transmit. Next slide.
Okay.
This is a second way of implementing it. It's we call it hardware-software implementation. Here, a platform is built on FPGA with embedded processor. Core 8051 is chosen as an embedded processor platform to prove the concept. Protocol functionality is built as software. RAM is used as persistent storage. Modules in hex is loaded in the PROM to validate the platform. Modules are developed and tested independently to port to the target. The system frequency is 12 MHz. Coding language is VHDL, and OpenKeel version 3 we have used for compiling it, software modules. Next slide.
Okay.
The next implementation is a pure software implementation. So the top level modules are shown here. We have bundle protocol server and bundle protocol agent, application agent, and a convergence module. The application agent will interface with the application. That sub-modules are commands, such that through command lines we can send bundles to this software module, and also it has different utilities to interface with the application agent. The bundle protocol agent The protocol functionalities are built in bundle protocol agent, where we have registration. It allows nodes registration in the endpoint, and also the registration can be made active or passive. It has a naming module for endpoint identification, naming resolution, and also it has routing module. The convergence layer we have built for TCP and UDP. Next slide, please. This is the bundle protocol sequence diagram. This depicts the sequence of operation in sending node and the receiving node. Next slide.
Okay.
These are the design approaches. The bundle protocol standard defines the DTN node can be a single process running on a general purpose computer, or it can be a thread in a process, or it can be an object in an object-oriented system, or it can be a special purpose hardware device, or it can be anything that the functionality is built. So in this we have a hardware implementation. It's a monolithic hardware design where we have a collection of hardware modules which will interact and realizes the functions. And the next implementation is a hardware software implementation where we can see an embedded processor, and all the protocol functionalities are built as a software modules. An operating system is optional in this model. And the third one is a software implementation where a general purpose hardware, the processor hardware is used like a single board computer, and on top of OS the software modules are built to realize the protocol functionalities. Next, please.
Okay.
In this slide we are comparing the different DTN design architecture. The hardware-based design, there is no processor chip or a software components in the design, and therefore it will be highly reliable, and also for fast realization of a flight-worthy implementation with minimum features, this model will be useful. But in this model it's difficult to provide all features due to the build-up of complexity, and in this it's not possible to accommodate changes at a later stage as it is a hardware implementation. The next, in the hardware software design, a processor is embedded in FPGA. Reliability of a software component in this also to be addressed for the total reliability, and the faster realization as the protocol features are implemented in software, and in this it is relatively easy to provide more features than the hardware implementation. Flexible to accommodate changes as it is limited only to the software modification. In the third model, we have in the pure software-based design. The design is based on a general purpose processor. Reliability of this will be fully of a software system plus the underlying single board computer, and the software testing and qualification takes longer time as it will have more features, and also in this model is most easy to provide all the protocol features, and also it is most flexible to changes as it is a fully software implementation. Next slide.
Okay.
This is a DTN application that we have envisaging. So here we have different DTN nodes. We have a MCC and then a ground station, then a ground, an orbiter, then lander, then rover. All this we have on ground. We have DTN is based on TCP/IP convergence layer. So MCC to ground station, it connects over a TCP/IP, and from the ground station to the orbiter, the bundle protocol and DTN is built on LTP, that's a link ladder transmit protocol, and it operates over TM and TC link. So LTP will build data reliability on telecom and telemetry link. And on Orbiter, we have one side we have LTP, and other protocol stack is on proximity. So proximity 1 will provide a reliable link using its sequence control operations to connect to the lander. From lander to rover, it can be any terrestrial network. We have chosen HDLC or AX.25 protocol, and all these nodes we have DTN BP sitting on that. The advantage is the mission can uplink the contact graph for a given period of time and automate the network operations. The command files are sent to the lander, rover, with the required time, with the required lifetime of the message for its operation. And also in this, we have provision for emergency commanding and emergency telemetry from the rover to the ground and from the ground to rover. Next slide.
Okay.
To conclude, the results of the study on DTN2 reference implementation are promising, and for its usage on a disconnected network. For DTN on space, a highly reliable and a lightweight version of the protocol suite is required, and different design approaches are compared here, and its prototyping were summarized. The protocol implementations need to undergo sufficient testing on simulators for all possible end-to-end scenarios, and also more simulations at ground are required for introducing dynamic routing of bundles for a large network. The emerging CCSDS standards on the DTN protocols will help the space agencies to deploy an interoperable network for future. Next slide, please.
Yep. So these are the references.
These are the references. Next slide.
Okay. Yeah, I'm on the next.
Thank you.
Thank you slide.
And also we acknowledge Dr. M. Annadure, Director, ISRO Satellite Center.
Thank you. Let's see if there are questions.
Are there questions? Oh, hold on. Oh,
Hello, I have a question. What missions does ISRO plan to fly the DTN stack on? And what has been the opinion of the use of DTN within your organization? That's all I'm asking.
Presently, this is running as a development activity. So this is not linked to any of the project activity. Once we are matured, maybe in future, we may try on our future missions.
Other questions? Wait. No, don't do that.
Can you tell us? There is a question to find out performance of the FPGA or performance of the DTN transfers. Oh yeah. Did you get my question? The question is regarding performance of FPGA.
Yeah. No, the comparison is not done on performance of performance part of it. The protocol conformance is the scaled down version. The protocol conformance is tested here. For example, in a fully software based system, the throughput, there could be some limitation, or in the even the software hardware approach, there could be some limitation in the throughput unless we address that. For example, the interface module, where we have the convergence layer has to be a hardware-based system. So the purpose of this is not to compare the performance from the throughput point of view. It's only the protocol conformance and the design models are compared here.
Thank you.
Thank you very much.
Other questions? Joel? No. Okay, thank you very much.
Thank you.
Thank you very much, guys.